Hi, everyone. Nice to meet you. Today, let's keep learning knowledge about expansion modules. And this part is for EtherCAT expansion module. Firstly, materials are basically the same as EtherCAT expansion module. You could review it in last video, Motion Control Quick Start 7, including the function of the expansion module. That is, these information. In short, expansion module is used to expand these resources. Here, we mainly talk about EtherCAT expansion module. There are two kinds of EtherCAT expansion modules, EIO module and ZMIO 310 ECAT module. It can be seen there showing some. EIO 1616MT is to expand 16 digital inputs and 16 digital outputs. EIO 24088 is to expand digital I/O and pulse axes, 24 inputs and 8 outputs, and 8 pulse axes. Then ZMIO 310 ECAT is one vertical expansion module. It can extend digital I/O and analog. And please note for EtherCAT communication, STP should be used. It can ensure data transfer with good quality. Next, let's see these two one by one. EIO 1616 is without shell. Others are the same as EIO 1616MT. EIO 1616 is powered by dual power, which means main power and I/O power are powered separately. Then EIO 24088 is powered by single power. Both I/O interfaces are with NPN type by default. Here shows EtherCAT expansion module wiring. It can be seen the wiring method is different from EtherCAT expansion module. There is no CAN H and CAN L. It only needs to connect to each EtherCAT interface. And there are EtherCAT in and EtherCAT out in each module. In is for controller. Out is for next one expansion module or driver. Please connect them according to this rule correctly. Then, obviously, there are two powers. I/O power is independent for EtherCAT modules. Therefore, the wiring is easy. Next, ZMIO3 then ECAT module. It can match with these submodules. This form shows their expansion resources clearly. Actually, analogs also support PNP and NPN. The precision is 16-bit. And for these two output modules, they need one separate power. And all inputs and outputs are with signal indication LEDs. Now, the wiring. Same as the I/O wiring method. Connect EtherCAT of controller to EtherCAT in a ZMIO 310 ECAT. Then connect EtherCAT out of ZMIO 310 ECAT to EtherCAT in a submodule. After wiring, how to use it? Before, it needs to edit one program for connected motors on EtherCAT to enable. That is, the initialization program. There are 5 steps. 1. Bus scanning. 2. Axis mapping and expansion I/O mapping. 3. Open the bus. 4. Clear driver errors. 5. Axis enabled. After this, you can use motion control commands to control bus access. And the application after enabled is the same as pulse motor, including motion commands. Later, this initialization program will be shown. Also, it needs to map expanded resources into controller local resources. Different EtherCAT expansion modules are with same I/O mapping and same axis mapping methods. And please note expanded I/O number and controller I/O number can't repeat. For EtherCAT, there are 3 kinds of numbers that are usually used. Number 1, slot number. It is the number on controller EtherCAT interface. Default is 0. And when there are multiple EtherCAT bus interfaces, corresponding numbers can be checked through this command. For controllers with only one EtherCAT interface, the slot number is 0. For controller with dual bus, the slot number of EtherCAT is 0. Of RTEX is 1. Number 2, device number, node. It means all device numbers connected on one slot, starting from 0 and numbered automatically according to connection sequence. Number 3, drive number. For this one, the controller automatically identifies the driver on the slot. And the numbering rule is the same as device numbers, but it only numbers for drivers, not for others. As we mentioned above, mapping is needed for expanded resources. CIO mapping firstly. It must be done after bus scanning. And when mapping, please check the controller max I/O number. Then use command to set. The command is node I/O. It sets I/O starting number, and input and output starting numbers of one single device are the same. Here shows the command usage. The first parameter, slot number, default value is 0. The second parameter, device number. The third parameter, I/O starting number. The number only can be multiples of 8. Then, see one example for I/O mapping. The first step, scan the bus. Then, use command to map I/O. This starting I/O number is mapped as 32. Next, I/O mapping. Actually, same as I/O mapping, but the command is node I/O. Slot is also slot number. Node means device number. The last one, I/O mapping number. Default 0 means A in and A out are set. If it is 3, in only is set. If it is 4, only out is set. For example, scan the bus. Then map I/O number. Access mapping. For bus access mapping is required. The command is same as ZCA and expansion access mapping. That is, access address. The usage is here. Target access number, slot number, and device number. This access mapping is edited in bus initialization after scanning the bus, before opening the bus. There is one example. Matches the first EtherCAT driver as access 0. Match the second EtherCAT driver as access 2. Match the third EtherCAT driver as access 1. Then configure them as EtherCAT access types. There are 3 optionals: 65, 66, 67. Generally, use 65, positioning mode. After bus scan, through * EtherCAT command, each node state and related information can be checked. These information. As usual, see examples for each kind of EtherCAT expansion module. EIO at first. 1ZMC for 3 to controller and 1EIO1616MT. Wired them. OpenZ develop and connect to controller. Run the access initialization program. Then open controller state window to check information. It can be seen the node number is 0 of EIO1616MT. And there are 16 inputs and 16 outputs. Then ZMIO310 expansion module. 1ZMC for 3 to controller. 1ZMIO310 EtherCAT communication module. 4 input modules. 2 output modules. 1 analog input. And 1 analog output. Wire them, use ZDevelop to run it and check information. It can be seen the starting number is 32. 60 for digital inputs and 32 digital outputs are expanded. Analog starts from 4. 4 analog inputs and 4 analog outputs are extended. Then another to EtherCAT bus reference configurations. 1ZMC for 3 to controller and 2 bus drivers. At this time, there are 2 nodes scanned, and they both are bus drivers. Each driver is with 1 motor. Access with node 0 is mapped to access 6. Access with node 1 is mapped to access 7. After bus initialization, you can get node information now through this command. The last reference configuration. 1ZMC for 3 to controller. 1EIO1616MT expansion module. And 2 bus drivers. The first step is still the mapping. Here, iOS mapping and access mapping are needed. Now 3 nodes are scanned. Node 0 is IO expansion module, EIO1616MT. Node 1 and Node 2 are bus drivers. Node 1 has 1 motor. The access number is 6. Node has one motor. The access number is 7. Then get the node information. 3 nodes all can be viewed here. At last, see one general routine of initialization program, which means the above configurations are valid. It has for parts: main program, bus initialization scanning program. It includes iOS mapping and access mapping, expansion I/O mapping. It is executed when there is expansion module. These initializations are completed. Access is enabled. Then it can run motion control programs. Next, open our Z-Develop. Firstly, execute EtherCAT bus initialization. Define parameters. Use global command to define its global type for cross-file calling. Usually these for constants are enough. Fill in them according to actual needs. Please note only this part you need to set. Max access is read automatically after connection. This defines the bus initialization mark, and the value is to judge the initialization state. Defines the total access number to be scanned. Execute initialization subprogram. Local definition means it only can be used in current subprogram. These 5 are defined here. Use for loop to close all access enables. The access type is set as virtual access, and the access mapping is set as empty address for following access mapping. Set access initialization as incomplete, and set scan total access as 0. Then stop the bus. Now all preparations are over. It starts to scan the bus. Judge it. If it fails, the program will report an error. Please check the reason. If scanned well, it will keep executing. The number of scanned devices will be printed. Judge whether it is the same as preset number. If they are not consistent, it would indicate. Next, access mapping. Read all scanned device information at first. Judge whether each node is with motors in order. If yes, do motor access mapping. Here, this for loop is for one driver and several motors. This target access number to be mapped. It equals to bus starting number plus bus scan access, and it can be seen the starting node was set at the beginning. It is 6. Bus scan number is initial value 0. Therefore, it is assigned from 6. That is, mapping the first motor on bus as access 6. Access type is 65, positioning mode. Then set separate groups for each axis. The number of total axes should add 1. Then map next axis. When all axes are mapped, exit the for loop. If there is no motor, it will call I/O mapping subprogram directly. This subprogram can pass parameters in the sub. I/O mapping starting number is 1024 plus 30 to current device node of expansion module. After mapped, print the number of total axes. Then open the bus. If failed, error appears. If opened, enabled will open. Use for loop to clear all driver errors and controller access state errors, and open each access enabled in order. Enabled, set the state as 1. Then configure local pulse access number. Then end subprogram and return main program. Now, bus initialization succeeds, and the mark value is 1. 0 means failure. While loop starts to execute the bus initialization again. Then judge initialization completion status. If yes, jump to motion control subprogram. Here is one simple example. 2 axes of line and circular motion. Okay, next, run the program. Connect to controller through controller IP. Download program into controller. If the bus opened, there would be information. At the same time, run the motion control program. Open controller state window to see slot nodes. Obviously, there are 3 devices. Okay, it can be known the initialization is very easy. In other words, it is easy to use EtherCAT expansion module. If you are interested in it or our other technical information, motion control information, please contact us directly. Welcome to be friends with you. Now, today's knowledge is over. Thank you for your watching. See you next video, and have a nice day.